can apply vector programming. So you've added concurrency, so you can evaluate multiple nodes at the same time. That improves performance, but it's also good for design applications. We have thread safety, so you can have multiple parallel actions coming in and they're processed in parallel, depending on how all they're conflicting. Distributed whole thing, so there can be multiple devices, each running a regular application, and they talk to each other. Distribution obviously comes with their problems. So ReScala is also able to propagate errors on kind of this overlay graph and handle the errors as part of the application process in an application-defined manner. And lastly, there's also automatic fault tolerance in case devices crash and reconnect. We provide eventual consistency of the overall system. This is my advertisement slide. Also, if you want to know more about these things, because I'm not going to continue to talk about them, let's say there's a talk Thursday in Studio One, and for distribution we have a talk on Wednesday, also at Studio One. So go visit them if you want to know more about ReScala. For the other topics, see the respective papers. So, I'm telling you about ReScala because the work on live programming is based on this framework of reactive programming, and as we've seen over the years, reactive programming seems to be well suited to a lot of different areas, and we hope that also, like in this work, we can use the same principles again, and also maybe provide some of these cool features. So we're trying to go live for a while now, but I've always had a few missing pieces, and that's what I'm trying to tell you here. So there is this very strong incentive for like reactive people with an interest in reactive applications to go live, because basically reactive programming, reactive applications are like spreadsheets. I'm not sure who the source on this wisdom is, but people at conferences often come to me and say, you should really tell people reactive programming is just like spreadsheets. That's all they need to know, they will understand. Which is kind of true. And then there is this really interesting workshop we found, which in the call for papers has the sentence that says, the best known example of live programming is the spreadsheet, which is probably true. So this is what we wanted to investigate, or are investigating. So this is like the question, right? Excel is an reactive application. So you have an Excel spreadsheet, you have some numbers in there, you have some formula in there that combine the numbers, and yes, you can do actions, so you can change some of the numbers. You have then the operators in there, which update whatever cells you are, and you have the reactions, which in the case of Excel is kind of the user parsing these actions. There may also be state somewhere in Excel, I'm not too familiar, but probably it's in there. That's kind of my proof that, yes, Excel is actually an reactive application. However, there's this missing bit that for me, for a while, it didn't quite work out. Because while this is true, what happens is if an application developer, like writes a piece of code which is run and then is the running Excel program. So a developer developing a reactive application does not actually do live programming, but develops a live programming environment, kind of, at least a little bit. So this is the final missing piece for me, which clicked in. So basically, that's the thing. So basically, you develop the empty spreadsheet. It's not filled with a program. That happens after developing the reactive program. So back to going live. So what was missing for me, I found in this nice paper from Kato and Goto from this workshop 2 years ago, which said we can expand the live programming benefits to non-programmers. And these non-programmers, which we call domain experts, that's the target audience that uses the reactive application to actually do some live programming. So that's then the users coming in this picture using the application. So we have this tool called Reactive Inspector, which is a debugger for reactive programming. And we've extended it to provide some sort, like some basic support for live programming. That's what I want to show you now in a live demo. Let's see if that works out. Good. So you might recognize the layout of this demo. I've reused it from some other application. So this is the temperatures application, which currently does nothing interesting. This is basically the empty spreadsheet, right? And there's like just an application. There's no way to interact with this application. But let's find out what it does. this is a web application, so we can open the Chrome Reactive Debugger. If you try to use the native tools to understand this application, you will horribly fail because it's all compiled code. However, I can activate my mouse. Yes. And then we can go to the Reactive Inspector tab. I hope you can more or less see the application. So, after reload the page to load the graph. So this is the main view of the Reactive Inspector is the graph at the bottom. That's what I want to currently to have you focus on. So we can see these operators in the graph, like the temperature operator up here and the time operator down here. There's always the name of the operator first and then the current value, where some values didn't change yet, which is said by this no change operators. Let me zoom out a little bit so we can maybe see not too much, that we can see the whole graph. And so it's a pretty simple application. So it's a pretty simple application because we try to understand it in just this live demo completely. So just by investigating the graph. So at the top there starts the action. That's something you kind of need to be familiar with. Which is this temperature action. And to the bottom are the operators, and at the bottom are the nodes producing reactions. So if you look at this graph, it has kind of a structure where we have this one arm here, which terminates, and then we have the other arm which splits up in a big way, and also has this incoming edge here. That's the overall structure of the application. So let's zoom in a bit now again. We can see the left arm. So if you want to understand this application, even without looking at code, there's somewhere temperature, and then there's this time, which has a value of 0, and then the internal node, which, well, it's part of the framework code. It's also shown, but that's not important. So this time value here seems to somehow correspond with this time value up there. So that's the first insight. So we're for now just looking at the static graph. Now on the other side, that's the more interesting part of the graph. So there seems to be the temperature, and then a less than 100 event, a more than minus 40 event, and a history of events, which currently is an empty queue, which, so to the right, there's nothing interesting, just believe me. But on the left here, the history is merged with this other branch coming down here, which has a selected aggregation, an aggregation, and then actually an aggregated value. So there seems to be some filtering and aggregating going on. That's what you kind of understand from just looking at the graph. However, seeing live examples makes the understanding much easier. So if you go back, like if you hover the temperature node, you may have already seen in the top bar, there's also the name of the node, and then there's a nice input field here, where we can, for example, fire a temperature value of 10. Now we've seen the application has been changed. So this is kind of already a cool feature because you just add a value and the application changes, which is not part of the debugger. That's just part of the application logic. That's something a reactive application always does, and that's something you kind of get for free in this kind of system. So you can see the changes directly in the application, like on the left. You also see the changes on the right in the debugger. So as you can see here, well, 100 is 10 is less than 100. 10 is also more than 40, so it was added to the queue of histories. Now also, in case you're wondering, the names of nodes for these operations are manually generated, so we cannot automatically infer the functions. So the 10 is added to the queue of histories and then somehow aggregated. If we add another value, say 25, we see that the aggregation, so we get 25 also added to the queue, and the aggregation seems to be just adding values, which, if we look a bit up, also corresponds to the name of the selected aggregation, some function. And this is another interesting feature. So for the aggregation value, you can select a couple of values, and this is something the application developer provides to the user of the reactive application. This is developer specified. You can implement whatever you want, and we'll see some more examples later. So we can change this function, say to the average, and then you see the application updated to immediately show the the average of the value. So there's one last missing feature I want to show you. And if you so you see up here is this bar of what happened. So let's, for example, let's pick this one node down here, which is one of these internal nodes, which currently has no value. And we may wonder, what is this node doing? What is it about? So if we go to the bar on top here, we can skip back steps in time. So if you notice, for example, from 4 to 5, we add one value here down in the queue. This is one of the time steps. Also, the application does not currently update. It's just the view of the debugger which updates. So keep an eye on this node below here, or if that's just the head of the person in front of you, just believe me. So we go back in time, and there it is at time steps 3 to 4. The value changes from like display hidden to some value. So this already looks like there may be a this has something to do with display. If we now want to see how this looks in application, we can do we can press the time travel button to reset the application to this point in time where there was no value. And we see, aha, we now go back one step into the future and time travel there. So this was the step where we added the first value. So seemingly, this value down there is to hide on the left side the empty queue and the aggregation value. That seems like a useful thing to do. So this is kind of how you can use the reactive inspector to understand the code and then also modify the code in slight ways. So this is only a very simple demo. Good. So, and maybe one more thing. So if you're now in this back in time world, you can also change new values. Also, press the button right. So you can, from the branched off history, then add new values. And there's maybe one last theory you want to check. So if you, for example, add a very, very big value, well, that's at a very small value. I like small values better. So that's at a very small value. We now can see that the temperature node added the value, but it was not added to the list of operations. So we can see then that this value was propagated to the less than 100 node, but not to the more than 40 node. This is another kind where you kind of, with a live example, you can test your hypothesis on the program, maybe modify the program a bit. And let's go back to the slides. So we in the future, we hope to extend this idea of enabling developers to write reactive applications which become live applications through added tooling. So there's obviously some elements we already think about that are obviously missing. Like, it would be really nice to show code automatically in a node if the person using the debugger has some knowledge of programming. It's just a useful addition. And also, it would be nice to have a UI to modify the operator graph. That's something Rescaler fully supports in all of the settings I've shown you. We can reorder the graph, it's just something that's not exposed in the UI yet. And I think many of you have better ideas of how to make this work properly, but it's definitely something we're currently looking into. Then there's this idea of developer controller. I've already showed you the selection box where there were multiple choices defined by the developer. But we could also have, for example, the developer say, these parts of the graph you may inspect and may change, and the other parts of the graph you should not touch. So we hope to help developers to kind of provide to the users a value in a live program. And for the code display, there's also a question, can we then move this one step further to also add modifications of code? Something we're kind of reluctant to do because we don't want the running program to break. We don't want to have a system that is so live that you can work around its guarantees. We want to keep the guarantees. But it may be interesting to, for example, have a limited DSL which does some kind of programming which cannot go against what the application developer designed the program to do, but still allow the user to add value to the project. So with that, thank you very much for listening to my talk. I've shown you how to hopefully help application developers to maybe very easily write reactive applications which can be used in a live setting, can be tuned during runtime, and maybe even help people understand what the application is doing in a general sense. Thank you very much for your attention.
First questions.
I also take comments or blame. Yes.
Yeah. So the developer develops in a textual language.
Yes.
And
so
what is shown here is a visualization of it.
So the application developer develops the thing in Rescala, which is an embedded ESL Scala. So it's a full traditional developing environment. And I don't want to.
And this is like a visualization of it.
And this is a visualization of the reactive application running at runtime. So a bit of a split there between the dead code you design and then the reactive application, which has this inherent live structure that we try to expose through this visualization and these tools, because the reactive application is really well suited to graphical modifications more than the traditional Scala building.
So I have a comment that would have been a really good thing to put on a slide.
Please.
In the company.
Yeah. I see. Yeah.
Did you eat your own dog food?
We eat our own dog food. So.
Is it being implemented in Scala?
Sadly, not yet. So this is the so it's a technical thing, obviously, but I think Rescala would be a really good target to implement the inspector with. This is currently based on the old version of the debugger we already had, which was back then not implemented Rescala because it also supported different frameworks. So it was made for RX and Bacon.js, and it's written in pure JavaScript in this sense. But that's definitely something I want to fix soon. Yes?
Through the whole presentation, it looked like it was a tool that the developer of, the maintainer of that temperature application used to debug their application.
Yes.
But then at the end, it sounded like you're going in a direction of this actually being for a tool for a user of the temperature application to do some sort of maybe live modification or analysis of it.
So it's the first step, right? So the debugger was designed for just the developer, but we're trying to add small features that they are still useful for developers, obviously, but we hope they will also be useful for users of the software to do small modifications. Yes, but we're not quite there yet, but we try to make small additions.
Any use cases you can imagine there? Like what type of modification would a user make?
So what I really would like to see, yeah. So it's a bit these two-sided thing, right? Because one big advantage of reactive programming is that it's all functional, it's statically typed. We have very strong guarantees of how the application will behave, and we want to keep that. But then allow modifications that kind of are within the restrictions of the application. I think what really works well is reordering parts of the graph graphically. So for example, adding nodes to be displayed on the UI, removing nodes that are no longer be displayed, modify the view to something that's suited to you as a user, because maybe you like to see these two elements at the same time and not the other two, which is something you could develop manually in the reactive application community, but we want to make the tooling easier for developers to produce these kinds of applications. That's always our focus, to give tooling to developers, and then maybe they can also help to provide for end users.
Maybe this was background you were assuming, but could you give some specific examples of problems for which this programming model is especially well suited?
Reactive programming? So it's actually not hard to find programs. It's hard to limit, I guess. So user interfaces are the most obvious thing. If you have a user interface, you probably have a reactive program already. There's basically no way around that. Rescala is a good language if you like the function reactive approach. There's also reactive programming language, obviously, but it also works for things like sensor networks, network events, robots that do processing of their environments, communication between like. If you, with your friends, have some smartphones and want to do some peer-to-peer communication, it's also a reactive system. Basically, everything that does not do a batch computation is a reactive program. More questions?
Okay, let's thank the speaker. So our next session starts at 10:30. I believe there might be some refreshments down in the basement, but in the meantime, Chris has agreed to get back up and answer questions if the audience would like to talk further.
All right, yeah, somebody.
Okay, cool. Oh, hey, great talk, Chris, by the way. I'm Paul.
Yeah, good to see you, Paul.
So, yeah, I guess what would you say, if you were going to do things again, what would you do differently, or how would you just approach the whole, what's the takeaway? What can we learn?
Sure. It really, really depends on your goal. So one very interesting thing that I didn't talk about here was that there were several points in time where we had a thing that we could have taken and made a product and made money on, probably been successful in some sense, assuming we did it well. But those things were never the original premise. The original premise for us was always, let's make programming more accessible. We could have taken the crazy database we built and built a database company. We actually had offers to do that. We could have taken the CardWiki thing and gone and built, matter of fact, a company did do that. It's called Coda now. Right, like there are a number of things we could have gone and tried to do that. Hindsight being what it is, I'm actually glad we didn't make those choices. I think we would have been sad that we had chosen not to. We were given this ridiculous opportunity, an opportunity basically no one's going to get again, right? Like, we had somebody willing to fund us to do 3 years of just crazy off-the-wall research and like try and do it productized, in a productized way. If I were going to go and do this again, I would focus basically solely on solving the modeling problem, because I think that's actually a decently tractable problem because we're so far in the other direction right now that like it's not hard to get much closer than we are to a reasonable modeling environment. And when I say that, I don't mean modeling the way we think about UML and that kind of stuff, like something that normal people might use. I focus pretty heavily on that, I think, turn that into a product. Don't worry too much about trying to be able to write compilers or anything like that, and that's not the point, even though a lot of our things were built such that they could do that. I would never do Kickstarter for a software project. For what that's worth, that was a very interesting and tough road. I think it's a bad model for software because with Kickstarter, the sort of assumption is there's a point in time where you're done. That assumption holds true for games, but does not hold true for like an IDE. It's never done. You're going to keep building and building and building and going on forever. And so it's just fundamentally that model sort of missets expectations. I personally wouldn't go down the venture-funded route again. We got extraordinarily lucky with the people that we worked with. We had amazing investors. I don't believe in the model, fundamentally. Like, that model is about being really large, and I think you can do a hell of a lot more with 4 people than you can with 30 people, much less hundreds of people. As a point there, when we were winding things down and we were trying to figure out where to go next, Josh and I just started going around meeting with a bunch of people and like asking these big startups, tell me about a problem. Like, if you were going to hire us, what would you have us do? We get them to tell us about the problem. We go home, spend a week or two, implement the entire system, and say, well, this isn't very interesting. Like, and also, hey, we're beating your system by 3 orders of magnitude. Right? You have 1,000 people, we have 2. Who's winning there, right? And so if you do go down the venture-funded route, there's lots of things they don't tell you. Like, for example, Originally, one of our suppositions was, okay, well, we'll raise a little bit of money and never raise again. And even people who bootstrap do get profitable within their like seed round or whatever, have to raise money again. This is the secret nobody tells you. Because your employees got a bunch of stock. That stock is worth nothing until you get it valued. How do you get it valued? You raise a round, right? Your investors don't get anything until the numbers start going up, right? There's this very strong pressure to sort of just keep raising and raising and raising and raising and growing and growing and growing.
Okay, so I just had a kind of comment, I suppose. I mean, so I really, really enjoyed the talk, and I think the thing that struck me most was the way you were not only continually sort of reinventing the goals all the time and then kind of reassessing what you were doing, but continually kind of reinventing how you were doing it. And that doesn't really resemble any business model I've seen, Chris. But it also doesn't really resemble any kind of research model either. Because researchers aren't continually doing that. They're much more narrow and focused, I think. And I'm not saying you weren't focused, but they're much more kind of single-minded in a sense. And I really like that openness. And I guess what struck me about it is it's much more like a form of exploratory play and much less like a business. And so I'd much rather think of it as a really successful creative activity rather than a kind of failed business model. That's what I see about to me.
Totally, yeah. Maybe I was a little too downer on it. Like, I think we did crazy and awesome stuff. Like, we explored points in space nobody else had explored before. I'm very, very proud of what we did, and I agree. I think in many ways it was about exploring the space of not just what could be done, but how you could do it. And there's lots of things there. So one of the points, I didn't make it in this talk, but I made it previously, was Eve's business didn't succeed, but one of the things we wanted was orders of magnitude, right? Well, we, a group of 4 people, were able to build a full relational database and IDE and a compiler stack, 3 of the largest pieces of software in the world, by ourselves in a month for 30 months straight. Like, we found that orders of magnitude thing. What was tough about that, it was never a thing you could sell. It was a way of working, right?
So maybe that goal was the wrong goal.
Could very well have been.
So the problem though is that, I mean, one moral one could draw is that you can't do research in a startup. But the problem is you couldn't publish that work either. This would be career suicide as a researcher, to be that just going around and saying, oh, this isn't working, I'm going to change fields, sort of, right? 3 or 4 times over a few years.
Yeah.
So we have to figure out some way to do this kind of stuff that's not a startup when it's not driven by publishing paper every 6 months.
It's a tough gig, right? Like, you talk with like the CDG folks, of which you were one, right? Like, you learn about how that lab is trying to find funding, and you look at Dynamic Land and how it's trying to find funding. It's just a tough gig. We're in this weird space where nobody thinks that work is really that important, which is sad because there's obviously huge benefits from it, right? Like, and there's a bunch of things that we certainly could push forward there.
I'm curious if there's specific audiences that you think are most fruitful for making programming more accessible to. You mentioned like scientists at the beginning, and then at the end you had running a business.
Yeah, so I think those are basically the two. It sort of depends on what your goal is. If your goal is just world improvement, hitting the scientists would be a good idea. But you have to realize that it's not going to make you money, right? Like, if you're trying to build a business, that's not going to be very successful, probably. Unless you manage to, attach yourself to like big pharma or something like that. If you actually wanted to make money and build a business and be able to continue to do this forever, kind of a thing, going down the small business route is probably the most straightforward version of this that could theoretically make money, right? You have to find ways that sort of directly make money for other people in order to make money, right?
Just in this context of making, like, I thought a lot about the statement earlier where you said that essentially you can't sell a developer tool. But then there are like counter examples to that. Like, I mean, JetBrains is probably across the board most obvious example, but then on the Mac in particular, Panic sells Coda and Transmit, tools for programmers that have tons of open source alternatives, even polished ones. curious, you kind of hinting at it, but just explicitly to hear your thoughts on that.
Both of those companies have been around for Panic, I think almost 20 years.
Absolutely.
JetBrains, even longer than that.
Yeah.
They came from a time when people did pay for tools and built up a following effectively. So like I used to be the program manager for Visual Basic and C# and Visual Studio, and if I remember correctly, it was like 70 or 80% of Visual Studio installs had ReSharper installed along with it, just JetBrains' adornment to Visual Studio. They make a lot of their money off of these weird enterprise deals that they got really early on in their sort of life cycle.
Yeah, just there are more recent counterexamples though, like Git Tower. That's like only been around for a few years. The practical Git client, and and obviously Sublime Text, which hasn't been around that long. Git application. I'm very curious. I mean, who knows how much money that's actually making? You know, you can use a trial essentially forever on it. But there are like more recent businesses. But it just seems like you hear this, and I'm making a developer tool that I hope to monetize. So, but I just see all these counterexamples, and then I also hear all these people saying it doesn't work, and I just can't figure it out. So.
I'll put it this way. I think you can build a lifestyle business, which is where Sublime Text ended up.
Absolutely.
Right. It's not that you can't make any money. It's that I bet you can't make enough money to have 10 people on staff, for example. Now, that being said, I don't know that having 10 people on staff is a goal that you should have anyways,
Yeah,
right? So who
absolutely.
cares?
Yeah.
I think there is certainly opportunity to make certain kinds of businesses work. You have to find that niche because there are so many open source tools. There are so many things, big communities that are just going to eat away at you in the long run. So you have to find something that nobody else is doing and do it much better. One of the things we learned with Lighttable is, I mentioned we could make programming twice as fast, right? Well, if you actually worked out what that means economically, that's like a $23 billion slice of money right there.
That was what I was thinking when you said it.
That's absolutely gigantic. Nobody cares. Turns out twice as good isn't enough. You have to be 10 times as good. And we couldn't come up with a way to do that with just a tool.
Perhaps maybe there's a trade-off between making the most money and helping the world. But assuming that your goal was helping the world, is there a specific version of Eve that you think is the most promising approach? And did you open source it so maybe other people can resume?
With the exception of that last one, everything we ever did was open source. So you can go and play with them and run them and all of that stuff. I think, like I said, if you're just looking at what's going to help the world the most, I suspect it's actually a variant of that CardWiki one. We learned a lot of stuff much later about how to fix the problems we had with NLP, to make it much more robust and to give people, like, one of the problems we had, so I gave the planets example. One of the things that really just like threw us for a loop was one of the people asked us, he goes, okay, cool, I see you have inhabited. I want to ask about uninhabited planets. And the question was, how in the world will we know that for arbitrary data and in an arbitrary system, what uninhabited means, right? We actually did eventually figure that out, but that was after we had stopped working on Eve. I realized, oh crap, like there's a very interesting pattern here that you can utilize, and it's about, having dictionaries and stuff. Anyways, but I suspect that one's probably one of the more useful ones because you can imagine what your goal is to create an environment in which people are better able to organize and ask questions. Fundamentally, and I made a big deal about this in my talk last year, like when we gathered examples of what people actually wanted to do with computers, it came down to just 3 things. And this was programmers, non-programmers, everybody, which was they want to collect some information, they want to ask some questions about it, and then they want to communicate the answers to somebody or something. Sometimes that's to yourself, right? So like we would go around and I didn't mention this talk, but like we went around to hundreds and hundreds of people and asked these questions, like what would you do with a computer? And so like a school teacher would say something like, well, I want to know when one of my students misses 2 homeworks in a row. I want like a notification or something that had happened. Or I want to know that one of my students' grades is starting to slip, right? Like, I don't need to monitor that perfectly. There's a system that can do that for me. They didn't want to build apps, right? They didn't care about any of that stuff. It was really collect some information, ask some questions, and communicate. And if you think about it, that is basically what the Office suite is for. It's not very good at asking questions. Excel is kind of the closest thing for asking questions. And it's easily the most successful piece of software ever made, right? So if you could capture that and upgrade it a little bit so that you could have the system start to understand your questions a little bit better and be able to answer them all the time, I think that would probably be one of the biggest things you could do.
So it sounds like you had an exhausting ride, so it's very reasonable that you would take some time away from work like this and like get a job. But I was wondering if there's any chance that we're going to get you back and in what form that would look like.
Yeah, I don't know. It's certainly very near and dear to my heart. If I were going to do this again, I would do something very, very different. And when I say do this again, I mean work on this specific problem again. I would actually probably not focus on trying to make programming accessible. I do what I was just describing, sort of work much more on this collecting and communicating side of things. I think, though, you could just, like I said, truly crush what we do in programming right now. And one of the things we've been trying to do is so we have this way of working, and we've been developing and using it in other domains. We've seen it be effective there. We've been trying to figure out what are the set of tools we could build that would just help us. Like, could we turn ourselves into just epic superhumans, right? Such that we're producing incredible amounts of stuff in a week, right? Could you get it down to a day? That was one of our goals with that Foursquare demo that I showed there. We actually did manage to build that in a day, which was pretty exciting. But like, how far could we take that, right? Could we get the system to start not in the standard programming synthesis kind of way, but maybe this model-driven synthesis kind of way? Describe some pieces of it and have a lot of the other stuff just generated for you. What would that look like? How do you deal with the fact that you now have generated and non-generated content, blah, blah, blah. And so I've been doing some sort of explorations about that on the side. I think I will probably eventually find time to work on that a bit more. So what I do now, so I work at a company called Looker, which is a business intelligence company, a data analytics company. And we are very specifically looking at how to do some of this modeling stuff I showed. So that actually is part of my job now. It's a big question of whether or not a big company like Looker is going to be able to take that and do something meaningful with it. They gave me a surprising amount of power, so maybe that might actually happen. So we'll see.
So you mentioned this modeling idea a number of times. So could you tell me a little bit more about, so like when I think about this modeling problem, I think like, I model some data and then like, it's a very like my understanding of this idea is very static. Like it's not, like maybe I want to build some application that does some kind of interesting domain specific like sorting or like, sort of representation of these things. So could you give me a little bit more of a sense of like how you would specify these kinds of custom dynamic behaviors from the modeling, given this like sort of model?
Actually, the last talk was a great example of how you do that. Like, okay. So reactive programming, we're thinking about things in terms of relationships between objects or functions, whatever, it doesn't really matter, is the way you end up modeling sort of these dynamical systems, right? And so I might say, for instance, if you imagine in a business model, because that one's easy to think about, like profit, right? Okay, profit is the sum of all my revenue and minus all my costs, right? Well, that actually that definition can be made reactive in the appropriate system. And the metaphor I give, I don't know if you've ever like been in a Prius and seen, they have those like that representation of the car's drivetrain and the energy system. You see energy flowing through that system. That's a model, right? It's just a representation of what the car system is actually doing. And it's just a series of equations, but data flows through it, right? And it's that reactivity that really allows you to do really awesome dynamic stuff.
I love the example that you use your technology to develop an app for your wife or your wife's mother? Because my wife's mother is also asking me how to do the same for our website. So, my technology is so widely applicable. I mean, I told her it's not meant for you because she doesn't know how to program, and I'm not as visual as you are doing right now. But how much, you say whether it's the next thing you would like to develop, how much do you think customization should be also be available to the users? Like they should be able to program whatever they want.
So customization at what level? Like making the UI look like what they want, or?
Not the UI, the functionality, the function they want.
Yeah, so an interesting thing I didn't show, because like it was just a very short video or whatever, in that last demo, was we came up with a way of modeling domains such that they could be composed. And the reason why I'm bringing that is, so I think what you want to do is, yes, you need to be able to say, oh, I'm doing support tickets, but I'm doing grill parts, right? And they have models, and they have parts, and they have all these weird things that are specific to me. But the vast majority of most domains is shared across everybody. So for example, I know that there is a domain in business for shipping stuff. Nobody's shipping really is any different, right? We all use the same companies. We all understand the sort of same dimensions and weight and all that stuff. There's no reason why I should ever specify that. I should just say, I'm gonna ship stuff, right? And I know it went by way too fast for you to see it, but like when I told it I was gonna put addresses in my support tickets, it started to ask me questions to help me better understand my own model. So it goes, okay, domestic or international? Because we're gonna store those wildly different, right? Are you only shipping, in the US? Okay, then you've got zip codes, you've got all these things. You're gonna have international addresses. You might not have thought of this. You need this, this, and this, right? Which countries? Oh, you're only doing Canada. Great, that's really easy. It's basically just like US addresses, right? And so I think you want a bit of customization, but you actually want that mostly at the data level, like the true, like these are the objects of my world kind of level of the world. I don't think you really need it in the UI. I don't, like, most people will use whatever. They're used to like software being garbage. So if you can make it even just slightly better, you're in a good place. So yeah.
So like Fred Victor, I think you're really great at these presentations and demos and getting a lot of attention and excitement around your work. And so I was wondering if you could give advice on how to do that really well, because it seems something you're good at.
I don't know that I'm going to have satisfying advice. So you brought up before, we're very interested in how we do things. This is something we actually looked a lot at over the years, trying to understand why is it that we were inspirational to people? Why is it that some of the guys, just as smart as I am and who worked with us, would talk and nobody listened? Like, why do people listen to me, right? Unfortunately, we didn't come up with a lot of answers. The one thing we learned, I think, and this is just, very geeking out a little bit about it, there's a very specific way that I talk. And I don't know how to teach anyone else to talk that way, but it seems, for whatever reason, makes people listen. I don't know.
You mean like the sound of your voice, or the cadence?
It's the cadence, it's...
This was an example.
One thing you learn is that putting emotion behind things has a huge, huge effect on people, right? And I sort of naturally just do that. Like I said, I'm a reluctant engineer at some level, right? Like I build software because it's one of the only ways to build the things I want, not because I actually like programming. And so I come from a place where I was big into writing. I was going to be a journalist, actually. I was an English and German major. I think a couple of things that are helpful is to ensure that you are always attempting to be relatable, right? I think there is this notion of what's called inferential distance, which is how many steps do I have to take before I understand where you're coming from? And the larger the inferential distance, the less likely you are to make any impact whatsoever, even if they fully understand you, right? Even if you can get them there, they're over here, they're not here. So yeah, I understood you, but I don't feel you, right? Like there's a different sort of thing. And so when it comes to effective communication, one of the most important things is just making sure you meet people where they actually are. The other thing is that most people really, really want to believe that things can be better. But they respond very well when you're honest with them about it, right? Like, I think this could be better, but I just told you all the ways in which we just failed, right? And I tried to tell you all the ways in which I think we can succeed and all the cool things we can do. But like, honesty builds trust. And so meeting people where they are and being very open and honest about what is true and what's not true, I think really helps.
All right, let's thank Chris again for